Good morning, y'all. For our next installments in our notes, I posted these videos on Campus, actually these pictures on Campus for you guys to copy down into your notebook, but I still wanted to go through these and kind of talk through what the whole meaning of all of this is, and then show you a couple examples by hand rather than just having you copy it all down. So the first page that I had you copy down was proving triangles are similar by angle, angle, and then side, side, side similarity. So let me explain what that means. So if we already know that triangles are similar, that means that all of their corresponding angles are congruent, and then their corresponding sides would be proportional to each other. But if we're looking at a diagram, or if we're given a problem where we're trying to figure out if triangles are similar or not, then we have to piece together some information. So for angle-angle similarity, if we already know that two angles within corresponding triangles would be congruent, then if we have two angles in one triangle are congruent to two angles in another triangle, then those triangles would be similar to each other. So what I mean by that is, let's look at an example or two here. So our example, we want to figure out, are the triangles similar? And these are going to be the same ones from our notes, but you could copy these down again if you really wanted to. So here's one triangle. I'm going to kind of cheat because Notability makes it nice for me. There's another triangle. So in the markings here, I'm going to put two different types of tick marks in the corners. So based on this diagram, because I have this angle is congruent to this angle, and then this one is congruent to this one, because we have two pairs of congruent angles, yes, these triangles are similar. They're similar by angle, angle, similarity. For similarity, you only need two out of the three angles to be similar to prove that they would be similar. Now, like an actual problem where we're dealing with some numbers rather than markings here. Here's one triangle. Here's another triangle. I'm going to mark this one over here. This has 35 degrees here. This is 70 degrees here. This angle down here is 75, and then this angle is 35 degrees. So based on what we're looking at right now, you can see that one of the angles is congruent in each triangle here, but we don't know anything about that missing triangle now, or that missing angle. Now we could easily piece together and say, well, let's find this missing angle over here. That would be 180 minus 70 minus 35, and that gives us a measurement of 75 degrees. Now, you can piece it together now and say, well, I know that if this angle is 75 and this one given to us in this other triangle, we've got two angle pairs that are congruent, so we know that these triangles are similar. If you wanted to go through and find this other angle here, you do the same thing, 180 minus 75 minus 35, and that would give you an angle measurement of 70 degrees. So either way, you can prove that all of your angles are congruent. So to answer the question, yes, by angle, angle, similarity. So that's if we're trying to prove if they're similar. Additionally, we could also have examples where we're given diagrams, and if they are similar, so if the triangles are similar, let's come up with a similarity statement. Write a similarity statement. So I'm going to do only one of the examples here, just for time matter. I'm going to do the example that in your book is number 4, but I'm going to do it as number 3 here. So there's one triangle. There's my other triangle. Intentionally not making them look the right way. But one we're going to call P, Q, R. And the other one I'm going to call T, U, and V. So for PQR, let's fill in some angles here. Angle Q is going to be 60 degrees, and then angle R is going to be 40 degrees. And then over in TUV, we're going to say that T is 40 degrees and V is 80 degrees over here. So kind of like the last problem that we saw, we would have to figure out what is our missing angle for triangle PQR. If I do 180 minus 60 minus 40, that gives me an angle measurement of 80 degrees. So this angle is 80 degrees over here. So knowing that, you can see, well, if this angle was 40 and we were told this one was 40, and then I found that this one's 80, this one is also 80 over here. So yes, our triangles are similar. I'll do this back in green. So yes, they are similar by angle, similarity. Let's come up with our similarity statement. So I'm going to name the first triangle PQR, and we have to name the second triangle based on that. So P over here, let's use orange, corresponds to angle V, and then Q would correspond to this missing angle U down here. And then finally, we'd have that R corresponds to T. So my similarity statement would be triangle PQR is similar to triangle VUT. Now that's angle similarity. The second one for this page, which I had on the back side, was called side similarity. And if we already know that if two triangles are similar, then their corresponding sides are proportional to each other. That means that if you match up the corresponding sides and reduce those fractions, then you would have the same reduced fraction for all three of them. That's like your scale factor. So if 3 sides of one triangle are proportional to 3 sides of another triangle, then the triangles are similar to each other. An example of that, so let's do an example here. So are these triangles similar? So for this example, I'm going to draw this little triangle here, and then this little guy next to it. I'm not going to name them. I'm just going to put side lengths next to it. So let's say this one's 6, 7, and 10. And then this one over here is 14, 20, and 13. So how do I figure out if they're similar or not? Well, how I can do that is I can match up their corresponding sides. So remember, when you're matching up corresponding sides, you're really just looking at like what's the smallest side in this triangle and matching it to the smallest side in the other triangle. And then you could say the second smallest or the medium side in this triangle compared to the medium side in the second triangle. And then you have the largest side in your first triangle compared to the largest side in your second triangle. So what I would do for this is I would say, all right, so I'm going to set 16 over 13. Does that correspond to 7 over 14? And does that correspond to 10 over 20? Now, if you reduce each one of these, you would see that 6 over 13 doesn't reduce at all, but then 7 over 14 reduces to 1/2, and 10 over 20 reduces to 1/2 as well. So these two are equal, but it's not equal to 6 over 13, so that means that they are not similar. It has to be the same proportion for all three sides matching up. Now, another example, I'll kind of squeeze it in over the side over here. We'll do example 2. Here's one triangle. Here's the other triangle. You gotta love notability. 3, 4, 6, and then 9, 18, 12. So like I did in the last picture, I'm gonna pair up the smallest side with the smallest side here, and then I'm gonna take the middle side to the middle side, and then finally take the largest side and compare it to the largest side here. So in doing so, we have 3 over 9. How does that correspond to 4 over 12? And then how does that correspond to 6 over 18? Well, if you reduce all three of them, 3 over 9 reduces to 1/3. 4 over 12 reduces to 1/3. 6 over 18 also reduces to 1/3. So because all three of these are the same, that means that yes, they are similar by side, 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 similarity. That little squiggle mark means similarity. And then one more example for side, side, side here. We're going to figure out, are they similar or not? And then if they are, we're going to write a similarity statement. So here's our example. If the triangles are similar, write a similarity statement. So let's do so here. Here's one triangle. I'm going to make these big. Here's my second triangle. That one kind of looks like a right triangle. I'm going to name this one HGI. And then this one I'm going to call WXY over here. So HG is going to be 8. HI is going to be 12. And then GI is 15. WX is 24. WY is 45. And then XY is 36. So let's piece this all together here. We're first trying to figure out if they're similar or not. So I'm going to match up my sides here. So HG is my smallest with WX, which is my smallest. So that would be 8 over 24. And then our second smallest here is 12. Second smallest here is 36. So that's 12 over 36. And then finally, oops, that's the pen. GI to WY here. That means that it's 15 to 45. And then if I reduce all of those, it's going to reduce all of them down to 1/3. 8 divided by 24 is 1/3. That's equal to 12 over 36, which is 1/3. And then 15 over 45 is also 1/3. So yes, they are similar. By side, 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 similarity. The question is, what would our similarity statement be? If I name this first triangle HGI, I, that's similar to triangles. So notice how I kind of went along the path there, HGI going this way. So I went the orange, see, I did it wrong. Went orange to blue to the final angle here. So that would mean that it's similar to X, W, Y. And again, by, side, 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 similarity. Now that's angle, angle, similarity, and side, 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 similarity. There was one other page that I wanted you to copy down from that's proving triangles are similar by side, angle, side, similarity. Now, the important takeaway here for side, angle, side, similarity is this. So, if one angle of a triangle is congruent to one angle of another triangle and the sides that form those angles are proportional, then our triangles are similar. This is the most important takeaway from that. The sides that form those angles. It has to be the two sides that are forming those two angles, or the two angles that you know to be congruent to each other. It can't just be two random sides within the triangle. So the difference between those two is, let's look at examples here. So let's say here's my first example. I want to figure out, are these triangles similar? So here's one triangle and another triangle. Let's say this angle is 85 degrees, and then this is 3 and 4, and then this angle over here is 85 degrees, and this is 12 and 16. So first, let's figure out if they're similar or not. So I see that we have two angles that are congruent to each other. So that's the first thing you need for side, angle, side. The second thing is you have to pair up their corresponding sides and see if they're proportional. So I've got 3 with 12, and then I've got 4 with 16. So let's do that. 3 to 12, is that proportional to 4 over 16? Well, both of those reduce down to 1/4. So yes, they are similar. By side, angle, side, similarity. Notice that the angle is in between both of the sides that you're looking at. Now, why I emphasize that is because, let's say here's a second example. I've got two triangles. This one looks like that, and that one looks like this. Let's say this angle down here is 50 degrees, this side is 7, and this side is 8. And then this angle's 50 degrees, this side is 14, and this side across is 16. Now, you might look at this and say, well, I notice that I've got two congruent angles here, right? 50 and 50. And then if you do set the sides proportional to each other, they would have the same scale factor. However, the problem is that if we're really focusing on these are the two sides that make up the angles here, these two sides where they intersect is not the angle of focus. So that means that these are not similar. I can't prove that they are similar based on the information that I have. So these two would not be similar. Again, because that angle that we know to be congruent, this angle and this angle, it has to be between the two sides that we're comparing to each other. So this was just a quick recap of the notes that I left for you guys. We will go over this the next time that I see you guys in the class session. If you have any questions, again, feel free to email me as always. Make sure you click that like and subscribe button to my YouTube channel here. Other than